Like terms. Please stop talking. We're going to take it back to the very beginning with like terms. There are some rules. First thing we're going to do is we're going to color code this expression. So I want you guys to color this 5 and this 3 green, the dark green. The dark green.
Okay. Which green?
I've said it 3 times now, the dark green. Oh my gosh. Don't even.
Look.
You guys, for real, a different class asked me 5 different times the color of this exponent 2.
Wait, what color is it?
To the point where the other students were like, you've got to be kidding me. Okay.
Were they doing it on purpose?
No, they just weren't listening. They were not trying to be funny like you guys are. They just
Wait,
weren't
what?
listening.
I don't try to be funny.
Jimmy's natural.
Yeah.
I like his hair. He puts 5 different products in it.
That's on the 2.
You guys, my son called me basic over the weekend, and I'm a little like
Offended?
slightly.
Oh,
So
shoot.
we were doing a guess the character game. We play those in the car all the time, and it was DC Comics, but I don't know many of the DC characters, so it was my turn to go. And so I, of course, was thinking of Batman. And he was like, that's so basic. And I was like, he's not wrong, but it kind of hurt my feelings.
That's orange, right? I called my mom basic because she called it pumpkin spice latte.
That is basic.
Well, yeah. Yeah, that's fair.
What about, you know the McDonald's? What's it called? The 4-leaf clover drinks.
The Shamrock,
Big
Shamrock
Mac.
shake.
Like the Big Mac.
Are the X's orange or red?
Is that a green?
Those dark green, orange, yellow. This little 2 here is going to be dark blue. The little 2 is dark blue. It rhymes. Dark blue.
Dark
Oh,
blue,
wait.
too.
2 equals
Yo. Oh, dang it.
Yo. Dog.
I got the wrong one.
That's okay.
Violet. Oh,
You're going too fast now. So I have to color them this way, okay? I cannot unmute this.
you had yours if you were Violet.
Nah, thank you.
That's so rude and disrespectful. I'm gonna report you to the speaker.
Oh, stop! So short.
Okay, so what we have here are the different components of an expression. We have coefficients, right, that are the numbers in front of the variable. What operation is happening between this 3 and this x? What is it? Adding, subtracting, multiplying, or dividing?
Adding. Right?
Chris? Dimitri? Multiplying, right?
Oh,
3 times the x, right? Yes, sir.
that's red, right?
It is. Okay, then we have our, guys, there's way too much conversations going on. Then we have our x's, those are our variables. We have an exponent. And then we have what's considered a constant, and that's just a term that only has like a symbol and a number. That's it. So -5 would be the constant there, right? So we have 5x squared is one term, 3x is another term, -5 is another term. You can't combine any of these because the variable and exponent doesn't match up for each of these. The only way to combine or to consider things like terms is if either they're all just a constant, or they all just have the same variable, or they have the same variable and the same exponent. That's the only way you can combine them. So we're going to practice finding terms that we could combine by color coding them. So the first thing we're going to look for are all the constants. So we're just going to color anything that's just a number by itself, either positive or negative. We're going to color them yellow.
What if it's 0?
0 is a value. Yep, that could be a constant.
Knew it.
So we're going to go through this little chart. It's going to end up looking like a quilt here at the end.
I wish it would go Steve.
We're going to need it for all the different terms that we can. There's 8 different types of terms in this. Yep,
Got it.
for real.
For real, Bob.
I would not lie to you.
When does fall break end?
In
2 weeks.
2 weeks.
Well, thanks.
Okay, the next one we're going to look for are any terms that have just an x variable with a coefficient. So 8x will work. This is orange. You can't have anything with an exponent because that's not a like term. Only a coefficient with the x or just the x works. X divided by 2 works. Negative x works. Only one I have left is 25x here.
Boom.
What about negative y?
Nope, because it has to be the same letter. Has to be the same letter and or the same exponent.
What if there's 2 x's?
Nope, doesn't count.
They said to be the same word.
Yeah, and exponent has to match too.
So if there's 2 like 2's and 2 x's, then that would.
What number are you looking at?
No, it's just
Oh.
like.
Now, you'll see how we break it down here. Okay, the next one we're going to do is anything with x squared, and that's going to be dark blue. Anything with x squared, so like negative 3x squared, plain old x squared,
That's blue.
it's blue.
That's dark blue.
Oh, I thought it would be.
10x squared,
You're still in color.
What about the negative x?
You only
x squared divided by 3, negative x squared down here,
had a color all the lines, but it's different.
Oh.
Yeah, that was down. No, you didn't.
Now we're going to look for anything that has a y. So we're going to use dark green
That's gonna get bottom.
for any term that has just a single y. So like
Oh, negative y?
a negative y works,
Oh, yeah.
negative 52y,
What about negative y to the second?
nope,
Oh,
the exponent has to be the same.
What about x?
No.
9y,
75 y. There you go.
please stop. Thank you.
Get a rhythm going.
You can see me, it's not like one.
Now we're going to look for anything that has y squared, and that's going to be light blue.
Light blue.
Light blue for anything with y squared.
What's y? I like that one.
It cannot have an x with it. It's just y squared.
Money she's looking at.
What about 36? Oh, whatever.
Negative 84. think it's gonna be light green.
It's gonna be purple.
Okay, so the next one we're going to do is red, but I need to we need to explain something down here at the bottom of the paper, right? So I need you guys to help me out. What's 2 times 3?
6.
6.
You want to
6.
like that?
If you want.
You don't have to, I'm just explaining it here. Yes, sir.
Shouldn't you do x, y, too?
Nope, because that has an x with it. It can only have y squared,
You don't know what?
okay? So 2 times 3, we all agree is 6, right?
Yes.
So what's 3 times 2?
6.
Please listen, I don't want you guys to miss this. So, please stop for 1 second. Thanks. So what I'm showing you here is it doesn't matter what order you multiply things, right?
Yeah.
So in that respect, x times y is the same as y times x, right?
Yeah.
2 times 3 is the same as 3 times 2. So when we're looking for like terms, as long as either of these have an exponent, they are the same. So negative 4xy is a like term to 90yx because you can multiply in any order. But neither of them have exponents, so that's why they are considered like terms. So we're going to color anything that has a single x and a single y as a like term. And this is red. If either of the variables has an exponent, it does not count.
Would x and y be one?
Yep.
I'm guessing the last one's gonna be purple.
Well, we actually have 2 more.
I knew it.
I think it's light green.
Light green and purple. Get it right, right.
I know, but I think
Violet.
light green.
It's purple.
Violet.
Literally, what kind of pencil says purple?
Okay, so now what we're going to look for is x squared with a y. So x is squared, y is not, and those are going to be purple.
So it's gonna
So
be.
x squared with a single y.
She said violet and white.
Well, that's because the actual pencil says violet on it.
See, I told you. Violet, purple.
X squared y.
Yolk.
Literally the exact same thing.
No, they're not. One's violet and one's purple.
Violet is like a blue.
Well, it says purple on the pencil too.
Purple.
And then the last one is x with a y squared.
I think
Those
this
would be
one's light
considered like terms.
There's only 2
I think this one's.
There was only 2 purples.
purple.
Way too high. A shade of blue?
Blue, yes, there you go.
Oh my gosh, Chris figured it out. But it's like
Did you
what
like search that one?
No, she was one like that.
Okay, so now we have all of our like terms by color. We can look back and see that certain things are considered like terms and certain things are not. We are going to stop there so that you guys have time to put the color pencils away. We will finish this tomorrow.